So, shall I start the class?
Yes, sir.
Okay, sir.
Okay. So, coming to the numericals from the module 2, which are very, very important. So, before start the numericals, I want to recall the formulas for what we discussed in the last classes. So, coming to the intrinsic carrier concentration. So, what is the equation for intrinsic carrier concentration? Any one of you, please tell me the equation for intrinsic carrier concentration. Ni. Ni equals to 2 into 2 pi kt by h square whole power 3 by 2 and me star ms star whole power 3 by 4 exponential of minus eg by 2 kt is the formula to find out the intrinsic carrier concentration eg by 2 kt. No need of equations for number of electrons and number of holes here. We don't have problems on that formulas. So one more equation for EF. EF is a Fermi energy level for intrinsic semiconductor. Equation for Fermi energy level at very low temperatures is EC plus EV by 2. But with the temperature, when the temperature is taken into the consideration, the formula is 3 kT by 4, 3 kT by 4 log ms star by m star by me star mh star by me star plus ec plus ev by 2. ec plus ev by 2. This is the equation for intrinsic Fermi energy level. So at t equals to 0 degree Kelvin or at t equals to 0, the equation will be ec plus ev by 2 only. Means at low temperatures, the Fermi energy level exactly in between the bottom of the conduction band to the top of the valency band. And after that, the equations from the Hall effect. First one, RH, Hall coefficient RH equals to 1 by n into E. First equation. And the second equation, the relation between the RH and EH, RH equals to Hall coefficient RH equals to EH by BJ. And one more relation between the VH and RH is Hall voltage, and in between the Hall coefficient RH into capital B into I by small b, and the current electrical conductivity rho equals to from the applications n into E into mu. From that, mobility equals to 1 by Ne into rho, but 1 by Ne nothing but RH. So RH into rho. All of you try to note down these formulas or take a screenshot. So one more formula for mu equals to, I am substituting RH equals to EH by BJ, or RH equals to B into I into, or VH into B by capital B into I. VH into I divided by capital B into, sorry, VH into B. This is a B into capital B into I into rho. These are some formulas which we use to solve the problems from the module 2. So first equation is the equation for intrinsic carrier concentration, at the same time Fermi energy level. So from the Hall effect, to find out the number of charge concentration. So Hall coefficient RH equals to, in terms of Hall coefficient RH equals to 1 by N into E. So when the electric field and current density is given with the including the magnetic field, we can use the formula to find out the Hall coefficient. and relation between the hull voltage and hull coefficient VH equals to RH into B into I divided by small b. So after that, electrical conductivity rho equals to N into E into mu. So from that, mu equals to 1 by Ne into rho, but 1 by Ne equals to, I'm substituting RH. So RH into rho. Instead of number of electrons, if the hull coefficient is given, we can use this formula to find out the mobility of the charge carriers. And one more formula, instead of RH, if the voltage is given, so we can use this formula, mu equals to VH into B into capital B by capital B into capital I into electrical conductivity rho. And these are some formulas to solve the problems which we used in the module 2. So try to note down or take a screenshot. So now I share the PPT which are related to the numericals. So I'm going to give 1 or 2 minutes of time. All of you be ready with your calculators to solve that problem. 1 second. Right. Yeah. So is the PPT is visible to everyone? Please respond, Amma. Anyone of you?
Yes, sir.
Yeah, okay. So note on the first problem. For intrinsic semiconductor with band gap of Eg equals to 0.7 electron volts, calculate intrinsic carrier concentration at 300 Kelvin if mass of the electron equal to mass of the holes equal to rest mass of the electron, nothing but 9.1 into 10 power minus 31. So Me star equals to, you can take an MP star equals to directly 9.1 into 10 power minus 31. So energy gap is given, Eg equals to 0.7 electron volts, and temperature also given. Use the first formula, Ni equals to intrinsic carrier concentration formula. Try to find out the intrinsic carrier concentration. So I'm going to give 1 or 2 minutes of time to solve the problem. All of you try to find out. The problem is for intrinsic semiconductor, we are going to find out the intrinsic carrier concentration. First, write on the given data. Eg energy gap is given in electron volts, converting into the joules by multiplying with 1.6 into 10 power minus 19. So after that, temperature is 300 Kelvin. Me star and MP star equals to 9.1 into 10 power minus 31 kg. So formula will be Ni equals to PPT PPT pen.
నిన్న క్లాస్కి వచ్చింది ఇవన్నీ సెట్టింగ్ చేయకు నా అంత కూడా ఖరాబ్ అవుతుంది
So write on the given data and use the formula Ni equals to 2 into 2 pi kt by s square whole power 3 by 2 and Me star ms star whole power 3 by 4 and exponential of minus Eg by 2 kt. Solve the problem. Try to find out. I will show the solution also. Within 1 or 2 minutes, all of you try to solve the problems. If you get it's good. Otherwise, I will show the solution also. PPT పైన ఎందుకు వస్తుంది? Anyway, any of you get the answer, Amma? Please say yes or no. Please say yes or no, Amma. At least give one text message. Keep one message in the chat box.
No, sir.
No, sir, you are always ready to say no. No one said we are trying, sir. Wait for 1 minute like that. No one said. This is very simple problem. See the solution. So energy gap is 0.7 electron converting into the joule by multiplying it 1.6 into 10 power minus 19 and T equals to 300 Kelvin. M naught, nothing but rest mass of the electron 9.1 into 10 power minus 31 and Boltzmann constant is the constant 1.38 into 10 power minus 23 joule by Kelvin. So formula will be 2 pi kT by s square whole power 3 by 2 and me star whole power 3 by 4 if the rest mass of the electron and holes are not same. So if in that problem the rest mass of the electron mass and hole mass are same, na? That's why I am taken here only. Within the bracket I am taken m naught kT by s square whole power 3 by 2 h square exponential of Eg by 2 kT and substitute directly. 2 into pi is 3.14 and m naught is 9.1 into 10 power minus 31 and Boltzmann constant is 1.38 into 10 power minus 23 and T is 300. Planck constant value we know already 6.625 into 10 power minus 34 into exponential of Eg. Eg is 0.7 into 1.6 into 10 power minus 19, that is minus Eg. I am substituting here and 2 into again K and T value, T equals to 300. So intrinsic carrier concentration Ni equals to 33.49 into 10 power minus 18 electrons per meter cube or per meter cube. And nothing but electrons only, na? Carrier concentration only, na? So charge carriers per meter cube. So someone 413. Are you there, Amma? 413. You get 1.1 into 10 power minus 10 power 10. Once recheck the answer, Amma. Once recheck the answer. If it is completed, I am going over the second one, Amma. Is it completed? Anusha, who is Anusha? Who is Anusha, Amma? అందరినీ మ్యూట్ చేసేస్తానమ్మా. I'm not going to give any option to you. If I am given option, so you are not utilizing properly. Please, when you join into the class, keep on mute. When I call your roll number, then only Ashmita. Who is Ashmita? Raising the hand, Amma. Ashmita, please rename with your rule number. So coming to the second one, and this is a 1 second. Yeah. So I'm given the formula also. All of you try to find it. And given data also I am given, and MA star and ME star equals to given 5. formula for EF. So what temperature would be the Fermi level shifted by 15% from the middle of the forbidden energy gap. Then Eg equals to 1.2 electron volts. Effective mass of the hole equal to 5 times of that electrons. Nothing but Ms star equals to 5 into Me star, or else Ms star by Me star equal to 5. This is the equation to find out the at what temperature would be the Fermi level shifted by 15% from the middle of the forbidden energy gap. Using that formula, I'll have to try to find out. So energy gap equals to 1.2 electron volts. Na? So multiplying it 1.6 into 10 power minus 19 to converting into the joules. So at the temperature T, at a particular temperature T, Ms star equals to Me star equal to 5, because of the effective mass of holes is 5 times of electrons. And this is the formula to find out the EF. And this is a solution for that. I'll have to try to observe. At 0 Kelvin, EF is lies between the band gap. So in EF equals to EF EV plus 0.6 electron volts. So after that, see the solution. At T equals to 0, we know that the Fermi level is exactly EC plus EV by 2. Na? Use that formula. I'm writing the in place of EF, EC plus EV by 2. Let Fermi level shifted by 15%. That is 0.18 electron volts. So added 0.18 electron volts to the 0.6. So the that will be 0.78 electron volts. So EC plus EV by 2 plus 3 kT by 4 log Me star by Me star. Me star by Me star equals to 5. And we know that EF equals to EC plus EV by 2. Na? EF equals to EC plus EV by 2. So I'm going to substitute in place of EF here, EC plus EV by 2 at T equals to 0. We need to find out Fermi level. At what temperature the Fermi level shifted by 15%. 15 nothing but 0.18 electron volts. Okay. So added to 0.18 to the 0.6 electron volts. It will be 0.78 electron volts equals to temperature we are taking into the consideration. This term also we are taking into the consideration, that is 3 kT by 4 log of Ms star by Me star. But Ms star equals to, we are having 5 into Me star, 5 times of effective mass of the electron. Nothing but Ms star by Me star equals to 5. That's why I am going to substitute here. So by subtracting these two equations, we are getting the temperature. EC plus EV by 2 going to cancel. 3 kT by 4 log 5. So T equals to, don't consider this equation number. So simplifying, we get T equals to 1729 Kelvin. At this temperature, the Fermi level is shifted 15% from the middle of the forbidden energy gap. Is it completed, Amma? Is it completed? Say yes or no. If you said completed, then I will go for the next one. Raise the hand, Amma. Raise the hand, then I can understand. If you raise the hand, I go for the next one. Only 28 raise the hand, Amma. 49. Two only. Two students only raising the hands. 8. 9, 10, 11. 13, 14. Take a screenshot, Amma. No need to noting down all the things. Simply take a screenshot. So after that, note down in your running books. Amma. So go for coming to the third one. So for silicon, energy gap is 1.12 electron volts. Find the Fermi energy level at 300 Kelvin if Me star equals to 0.12 into M naught and MP star equals to 0.28 into M naught. So similar problem. So EF equals to 1 second. So what is the formula for EF? EF equals to EC plus EV by 2 plus 3 kT by 4 log MS star by ME star. MS star by ME star. Right on the given data and temperature is given as 300 Kelvin and Me star equals to 0.12 into M naught. M naught nothing but rest mass of the electron. No need to substitute. Here go that M naught going to cancel here. MP equals to 0.28 into M naught. EG equals to 1.12 electron volts, converting into the joules. How we are going to convert? By multiplying with 1.6 into 10 power minus 19. This is a given data. Now this is a solution for that. All of you try to note down number. So here I am going to ask one thing. So here I am taken EC plus EV by 2 equals to EF. Here I am taken, wait. EC plus EV by 2 equals to EF. This is a general equation. But here I am taken EC minus EV equals to EG. Why I am taken EC minus EV equals to EG? Actually, the Fermi energy level for intrinsic semiconductor is EC plus EV by 2, right? So instead of EG here, I am taken EC minus EV. That one also okay, but here how I am taken EC plus EV by 2 equals to EG by 2. Any one of you, please tell me why I am taken or how I am taken EG by 2 equals to EC plus EV by 2.
Yeah,
So from this formula only I am taken EC plus EV by 2 equals to EG by 2. How it will be, I will explain. So EF equals to EC plus EV by 2 na? EC plus EV by 2 na? So here EC plus EV equals to 2 EF, right? So I'm going to EC, we want the EC plus EV by 2 equals to EG by 2 na? So substitute EF equals to EC plus EV by 2 directly. So from that formula only we are getting EC plus EV by 2 equals to EG by 2. So both sides multiply with minus 2 EV. Okay. So or else EC plus EV minus 2 EV equal to 2 EF minus 2 EV. So here EV minus 2 EV nothing but EC minus EV equal to, if we are taken 2 as common, so EF equals to, I am substituting EC plus EV by 2 minus 2 EF, 2 EV, right? So by cancelling 2 and 2, I am getting EC minus EV. Wait. One second. By taking EC plus EV by 2 equals to EG by 2, I am substituting in place of here EG, sorry. So EC plus EV by 2 equals to what I am getting here, EG by 2 na, substitute here directly, EG by 2. Energy gap is 1.12 into 1.6 into 10 power minus 19 by 2 plus 3 by 4. K value is Boltzmann constant is 1.38 into 10 power minus 23 and temperature is 300 by, don't substitute log 5 because of here 0.12 divided by 0.28. Don't substitute here 5. Taken log 0.12 divided by 0.28. And tell me the answer, EF equal to. Is a 4 3 is 4 7. 3 by 7 you are getting actually. Log 3 by 7, find out. Be ready with your calculators, Amma. When we discuss the problems from any module, be ready with your calculators. I already told to you. Please tell me the answer, Amma. Is it correct? TF equals 0.576 electron volts. Is it correct one? No one responding. Yes, sir. 431. Okay, Amma. Coming to the next one. Fourth one. Calculate the hull voltage developed across the width of the slab of metallic slab carrying a current of 30 amperes subject to a magnetic field 1.75 Tesla. The magnetic field is perpendicular to the both plane of the slab and the current. Already we know in the Hall effect, all the three components are perpendicular to each other. The thickness of the slab also given. T is given 0.35 centimeters. The concentration of free electrons in the metal is 6.55 into 10 power 28. So concentration of electron, nothing but N. N is given. So to find out the RH, use the formula RH equals to 1 by N into E. Find out the RH. If in the problem, if RH is required, find out the RH. RH equals to 1 by N into E. Using this formula, and we know the N is given, concentration is given, concentration of electrons is given. So find out the RH if it is required. So after that, calculate the hull voltage also. What is the formula to find out the hull voltage? VH equals to RH into B into capital I by B. B nothing but thickness of the slab. So to RH is not given directly. That's why use this formula RH equals to 1 by N into E. Find out the RH first of all. After that, using this formula, find out the hull voltage developed across the material. Is it clear, Amma? So number of electron concentration is given 6.55 into 10 power 28. Current is given directly. Magnetic field also is given 1.75 Tesla. Thickness of the slab also given. So does directly substitute in the formula to find out the hull voltage. This one. Instead of RH in the formula, I am taken directly N into E. వస్తుంది. Is it clear, Amma? Sir, where RH value, sir? So RH equals to 1 by n into E. Instead of RH, I am taken here 1 by n into E. Because of you know the formula, na, RH equals to 1 by n into E. Sorry, 1 second. So actual formula will be RH into capital B into I by small d. But RH is not given directly. So number of electrons is given. So using that formula, RH equals to 1 by n into E, I am going to find out the RH. Okay, number of electrons and charge of the electron. That's why I am taken n into E. In place of RH, RH equals 1 by n into E na. So denominator lo instead of D, I am taken n into E into D. Capital B into I divided by small n into E into D. Is it clear? Rule number 60. Is it clear? Okay. So coming to the next one. Calculate the resistivity if the intrinsic carrier density at room temperature is in germanium is 2.37 into 10 power minus 10 power 19 electrons per meter cube, and the electron and hole mobilities are given 0.38 and 0.18 respectively. First find out the conductivity. Take the formula of conductivity formula, rho equals to n into E into mu. So first of all, write on the given data. What is the data given? Intrinsic carrier density Ni. Ni equal to 2.37 into 10 power 19 per meter cube, and mobilities of electron. Mobility of electron mu n equal to 0.38 and mobility of hole mu p equal to 0.18. So calculate the resistivity rho. So but we have a formula in terms of conductivity n into E into mu. If you are taken Ni, here we are taken mu p plus mu n. Okay, so Na is given and charge of the electron we know 1.6 into 10 power minus 19. Mobility of electron and mobility of holes also given. So after finding the electrical conductivity, so what is the relation between the conductivity and resistivity? Resistivity equal to 1 by conductivity. Using the two formulas, all of you try to find out. I'm going to give 2 minutes of time to solve. All of you try to tell me the answer. Make it fast. So actual formula will be rho equals to n into E into mu. So, but we want here Ni is given, intrinsic carrier concentration is given. If we are taken intrinsic carrier concentration, we need to take it down, and mobility of electron and mobility of holes we have to take. That's why instead of n into E into mu, I am taken n into E into mu p plus mu n, or mu n plus mu p. Both mobilities we are taking into the consideration. Of finding the conductivity using the formula resistivity equals to 1 by conductivity. Tell me the resistivity value. Make it fast, Amma. It's already 1:25. More 5 minutes only left. We are going to remaining. I think 4 to 5 problems are there. I'm not going to share the solution for the fifth one. I'll have to try to solve at your own, and we'll discuss about that fifth problem in the next class. And next one, note on that sixth one, all of you. Calculate the intrinsic charge carrier concentration for germanium at 27 degree Celsius. For germanium, atomic weight is 72.6 and density 5400 kg per ml, and band gap is 0.7 electron volts. No need, that values are no need. Take the formula directly. Intrinsic charge concentration, Ni. Ni equals to, what is the formula? 2 into 2 pi kT by h square whole power 3 by 2 and me star whole power 3 by 4 exponential of minus Eg by 2 kT. Use that formula. I'll have to try to find out. Note on that one. More 3 minutes only left. I'll have to try to note on the problem, remaining problems. We'll discuss about the problems in the next class. Meanwhile, I'll have to try to complete the solutions or get the solutions. And seventh one, the intrinsic carrier density is 1.5 into 10 power 16 per meter cube. If the mobility of electron and holes are 0.13 and 0.05, calculate the conductivity. Fifth, in the problem 5, we are using that formula. Fifth question is 0.47 ohms. So we'll see the solutions in the next class. Amma, someone posted the answer, but we'll see the answers in the next class. First, note on the problems or take a screenshot directly. The intrinsic carrier density. What is the formula here? Rho equals to N into E into mu. Formula for electrical conductivity, rho equals to intrinsic carrier concentration into charge of the electron into mobility of electron and mobility of hole. Me and M. Okay, use that formula, try to find out about for seventh one. So coming to the eighth one, for a semiconductor, the Hall coefficient is minus 6.85 into 10 power minus 5. So all we do, then we can say the type of material is N-type material. No need to take the minus symbol when you calculate the density or mobility charge carrier density. No need to substitute minus. So this minus symbol is used to identify the type of material. So electrical conductivity is given. Calculate the Coulomb density and mobility of charge carriers. Using the same formula, I'll have to try to find out. Instead of N into E, take the Hall coefficient. Hall coefficient equals to 1 by N into E. Use that formula, including the electrical conductivity, rho equals to N into E into mu. And ninth one, note it down, number ninth one. So RH is given, Hall coefficient RH is given 3.66 into 10 power minus 4. Its resistivity is given 8.93 into 10 power minus 3 ohm meter. Find the mobility. So first of all, find out the conductivity using the resistivity. 1 by rho, conductivity equals to 1 by resistivity. Use that formula. First of all, find out the conductivity. After that, find out the mobility also using the RH. RH, what is the formula for mobility? Conductivity rho equals to N into E into mu. Use that formula. All of you try to find out the mobility. So we will see the solutions in the next class. In between, all of you try to solve the problem somehow.